Yeah, well, I think also I just noticed or I read somewhere that there are something like 125 gigawatts of renewable energy in the development queue in Texas, and their daily requirement never exceeds like 80 gigawatts. So if these things go to pass, they're going to have excess capacity out the wazoo. So it
Great.
doesn't seem likely that there's an economic argument for that much renewable generation in Texas unless they have some sort of interconnection, which they currently don't have with other grid operators.
Hmm.
So,
Sure.
so we'll have to see what they're up to down there. But the general assumption, it was very interesting to see the conversation with the students because, um, almost like America, the students sort of came out 50-50 split because of a lot of the problems with the Texas grid is that it's kind of ultra deregulated. And about half the students said, well, that's good because it does provide for lower cost structure, which is true. Um, but when there is a problem, there's a big problem. And a lot of the students said, well, you knew the job was dangerous when you took it, deal with the problem. You're accepting the benefits of an unregulated environment, accept the consequences as well. And some of the students were saying, no, we need to have more regulations into this. But the counter argument is, would you be willing to pay for those
Sure.
additional requirements? And it was kind of 50-50. Of course, none of these students pay their own, utility bills anyway. So, who cares? But
If
It's all
you,
academic so far, huh?
yeah. Well,
Until their check is hit.
It really sort of lays down the whole idea of deregulation versus regulation, because when there is a catastrophic problem like the one in Texas, there are many, many, many millions of dollars of cost, not let alone just the aggravation and potential loss of life. Do those costs balance the added costs of the regulation? Maybe not. We just have to kind of look at that. And is the regulation common sense, or is the regulation a bit over the top? And it was a good discussion because we sort of came down on California is overregulated, Texas is underregulated. Where is the correct balance? Where do we go, with that? Because obviously a grid needs some regulation. You can't just throw it open to all. So how do we march through that maze? Hey, Tim. So
national energy policy would be a good idea.
Yeah, national. Well, we are one country, but we seem to be have national policies when it suits some players, local policies when it suits others. Kind of leads into some of the news of the week I found interesting. Here in Ohio, 2 Republican state legislators are introducing a bill that says at the township level, you should be able to have referendums to determine whether or not a solar or wind site is developed in that township. So if 8% of the registered voters sign a petition, then the project is on hold until the next election, at which it must be approved by the majority of the voters before it can go forward. Now, there is no similar call if there's a coal power plant or a gas power plant or any other kind of power plant. It's only wind and solar, which is interesting.
Well, why is there a call for anybody? I mean, if I bought the land and I'm not polluting and I'm not, it's coal just as well. I mean, if I'm not breaking any of the other rules, why does the township get to decide whether or not I can run a business?
Because it's an end run. It's an end run around the Public Utilities Commission by the local legislatures to try and put a stop to development they don't like. I mean, that's the reality of it. They're claiming it protects local homeowners' rights. The developers claim it puts 55,000 solar jobs in Ohio and $18 billion of development at risk. neither of them is being overly truthful,
Yeah.
but it really is one of those, let's give local control. If the locals agree with me, let's make it national. If the national agree with me, it's that kind of regulation. So
That's an oil and gas bill, Jay.
pardon?
If it's only specific to the renewable energy, it's an oil and gas bill.
Oh, no doubt that's where a lot of the funding is coming, and certainly a lot of the funding for the anti program, because there would be a big voter, turnout, stop the wind farm kind of thing. That would come from, traditionally it's come from the American Natural Gas Association. It's come from the Koch brothers. Mm-hmm. Those guys have funded those kind of things. So, I mean, we'll see where it goes, because it's also interesting at the same time, there's a bill in the same legislature to prohibit homeowners associations from unduly restricting the right of homeowners to install solar on their home. So it's like there's one bill promoting solar, there's another bill against it. Who knows where they're going to come down on this, but utility scale solar is a huge thing right now. In fact, I was just looking at the numbers. They came out for 2020, and growth of solar in the United States actually grew 43% over 2019 in the year of COVID, which is kind of amazing, since we kind of all assumed at the beginning of 2020 that there would be a slowdown. And it actually was a record-breaking year by quite a large margin. So a 43% growth over 2019, and just by coincidence, solar accounted for 43% of all of the new energy installed in the US. Wind was 39%. Pardon?
Was the 43% just industrial, or was that industrial and individuals? I'm just curious.
It's everything. But the vast majority of that is utility scale. Okay. So the big operators are putting in huge plants. In fact, in the news I was looking at, like Wisconsin had plans to put in a 325 megawatt solar installation. I mean, it's all over the place, 60 megawatts here, 25 megawatts there. Hundreds of megawatts going in. And the reality is, because they found that the economics are there, where to put in a new solar plant is cheaper than to operate an existing natural gas or an existing coal power plant. So the only reason really you want a coal or a natural gas power plant is to develop or to deal with peak load demand. So you run the solar when it's available, and then you have the natural gas to deal with those reserves, and when there's a higher demand than normal, or at nighttime or whatever. But then, of course, that goes away with battery storage. And to just let you know, batteries in the fourth quarter of 2020, so just in that 3-month period, grew 182% over the third quarter, which represented the record before that. And actually, battery installations, storage battery on the grid in the fourth quarter of last year doubled the total installed capacity. So in a 3-month period, we doubled the amount of batteries deployed on the grid. I know, Bill, you were just mentioning Tesla with a big battery bank in Texas. Well, that's happening all over the place. And so once you have that battery storage, then the peak load demand of natural gas doesn't go away, but it's less required. It's less important.
Jay, is there any way to tell how much of that is, I'm just curious, driven by the economics and how much is driven by regulation? And the reason I ask is because our company now has a solar array at its headquarters. I think it's a parking, one of these parking situations where they put it all up, and it was subsidized by the local utility in Delaware, because they had targets that they had to reach. They had to have X amount of installed renewable energy by the end of the year, whatever it was.
Right.
And so they came to us and said, hey, if you guys put this up, you've got a lot of land there. If you want to put this up, you can meet, you get to meet your ESG targets, which is the environmental something and governance, sustainability and governance, some kind of corporate targets. And we get to meet our other stuff, and we will, we'll put the money up front, and you can pay it over time, or do it as a, instead in lieu of the electricity.
Yeah, a power purchase agreement.
More or less. Mm-hmm. And they said, we can, but the only thing you can't do is you can't claim this in certain places, because we want X amount of installed renewables in, which we're required to do by somebody. The FERC, yeah. I don't know who it was.
Well, that's probably the state renewable portfolio standard.
Okay.
And there are portfolio standards available in a number of states, although those have become less important in recent years. Mm-hmm. So they are a driver. It is a driver in some places, but it's not so much of a driver that unless the economics make sense, you're going to do it.
Okay.
What is really driving it at the moment at the corporate level is a lot of these corporations are coming up with their own renewable goals.
Yes, they are.
It's part of their own, like, we want to be green. And some of the podcasts I've listened to who talk with a lot of these corporate heads, I guess we're coming to the age where their kids are becoming aware enough to give their parents hell when they go home about global warming and what are you doing?
It's ESG, and it's a new standard. And with Biden, there's been in the news, especially in the last 2 months, because a lot of his SEC people have started making rumblings that they're going to start measuring this and doing it. But it's environmental, I think it's sustainability and governance, and it's all these, we're a good guy. It used to be, you got your tax rate, you got your EBITDA, and now you've got your ESG, and you want to be, if you want the housewives and the whoever's, all the younger people, like you're saying, who have a higher, who don't pay the checks yet, but do understand that the good things should be happening. They buy stuff from people who have a higher ESG rating, or, like Procter and Gamble's of the world. They want to be in the top level for this.
Yeah, and I understand too, and I might have the name of it wrong. You would probably know, Don. It's basically a portfolio management company called Blackwater, I think. I kept thinking those guys.
It's a hedge fund, yeah.
Yeah, and they manage, trillions of dollars of stuff. And they just recently came out and said they will no longer support coal, for example. Yeah. They're out of that business. Now, it's kind of one of those things where coal no longer makes financial sense, so that makes sense to them, but they're trying to paint themselves as green. And Microsoft just came out and said they're going to do not only carbon offsets for what they do today, but they're going back to the beginning of the dawn of the company and offset all carbon emissions since they were created. So they're going to outgreen the greenies, and the banking industry is sort of coming out and saying, we will not fund any of these environmentally insensitive. So there's sort of a tsunami with the Biden administration coming in and saying, we're going to put all of this against a carbon neutral backdrop. The banks, the funders, the management firms, the corporate philosophy, the renewable portfolio standards. But it all is really being driven by the economics, because they just ignore that anyway. If it was more economic for them to install coal, for example, than solar or wind.
Yeah, I think some of it is. I think some other things for the consumer products. We make products that go to P&G or somebody else who sell to consumers, and they are the ones who are putting a big push on to say, our consumers don't want to buy anything that's got microplastics. It doesn't have something that's not carbon. It used to be, we don't use child labor and beat people. Now it's, we don't use little pieces of plastic or we don't kill birds or whatever else it is.
Well, it's part of the cancel culture, You know, we don't want to support anything we don't like. Well, cancel culture is also how we got apartheid to end in South Africa. You know, it's one of those things. It makes perfect sense, regardless of your political ideology. If you don't agree with the behavior of the people you're buying stuff from, don't buy stuff from them. And they're beginning to feel that pressure, whether it's real or imagined. They're beginning to feel the pressure.
And that's the question, whether it's real or imagined to some extent. You know, some things make sense. Some things are just people's political, you know, some groups are in the more favored, and they get their ideas put forward, and they may or may not make sense. They may or may not make sense economically or in real life, but you got to deal with it.
Yeah. And fortunately, I agree with some of these things, not all of them, you know.
Yeah.
But you know, it's kind of nice to be on the other side of it for a brief period of time, where renewables is winning and the coal power plants are being shut down, where before, you know, the rivers around here were orange and nobody asked me for a township referendum on whether we liked orange rivers or not, you know. So,
they weren't orange, Jay. They were just a little cloudy sometimes, I'm sure.
No, I swear to God, when I used to go to high school, you'd look out of the bus and literally Monday Creek and Sunday Creek were bright neon orange. And that was all from the runoffs from the coal mines around this region. So it was pretty amazing. So anyway, those were some of the latest news there that I had. Did anybody have anything to bring up for the good of the cause? I think, Don, you had something held over from last time.
I have a question. Battery banks. So I've got 32 batteries in a bank now. So they're 12-volt batteries. So there's, you know, 8 rows, you know, 2. So it's 32. So there's 8 different cells, or whatever you're going to call it. I'm going to put another 16 batteries onto the same bank. So, and they each, all 3 of, I have 3, you know, 3 now, and I'll put 4 inverters, and they're all drawing directly from the banks equally. The question I've got is, and I've heard this, and I'm not sure if it's right or not, so I'm asking, if I put the other batteries on, do I have to make sure that they're the exact same voltage at the time that I put the new batteries in, or will it equalize over time? Or the way that it was explained to me is, if you don't put them at the same voltage, let's say you have one at 50 and one at 55, well, it's all going to go up and down together, and your ones that are at 50 are never going to equalize and be, you know, it's never going to work out.
Okay. Yeah, well, first up, let me understand your configuration. It's a 48-volt system. Is that correct? Nominal?
Yes.
And you've got 4 in a string. And at this point, you've got how many strings?
It would be 8 strings. Well, there are 8 strings, and they put them together. So there's 8 in, I'm going to say it backwards, 8 in series to get me up to the 48, and then they all run parallel up.
Okay, so 4 in series to get, these are 12-volt batteries or 6-volt?
Yeah, 12 volts.
Okay, so 4 in a string, and then you have 8 strings, and they're hooked into multiple inverters. Is that right?
Right. So there's 3 inverters. There'll be 4, but at the end of each of the banks, I got the negatives and I got the positives. And out of the negatives, I got 3 going up to each inverter and 3 positives going up to each inverter.
Okay, well, good. Because one
to each, but yeah.
Yeah, because basically, what I have been told, and I've never tested it or done a whole lot of research, but putting more than 3 strings in parallel can, you know, provide undue stress on your battery bank and may shorten its life. So that's one thing. So if there's 3 in parallel going to one inverter and 3 in parallel going to another, and they're separate systems, that doesn't matter. You know, you've stayed within the 3.
Right.
If you have a battery that goes bad, you know, you replace one battery and put it within a string, then that string will equalize. So the new battery will become basically an old battery fairly quickly. You know, so what they recommend is, let's say you've got a battery bank that's 4 years old, and one of them goes bad. One of the batteries, for whatever reason, just goes bad. They would recommend at that point you replace all 4 of them, because otherwise that new battery you put in there is going to be 4 years old, in quotes, very quick. But hooking them in parallel doesn't have that same effect. It's only when you're hooking them in a string. So if you were to put 4 new batteries in a string, that string, you can think of it as its own little unit. And it's not like it's going to be drawn down to the working ability of the other batteries, as long as it's a unique string that all batteries are new in.
Okay, it is. Yeah, that makes sense.
Yeah. You'll just get additional amps added into your system. The voltage will blend. You know, like if one's coming out at 48 and one's coming out at 52, you should get a 50 volt blended voltage, you know, by the time it comes out. But I don't think that has any effect on the other strings. It's just the output.
Yeah, but I mean, the new strings, I guess what somebody had been trying to tell me, I thought, was that if I put in, let's say, 4 new strings, and they're at 50 volts and the others are at 52, that I would always leave a, you know, as power came in to power them back up, they would always have this 2 volt differential going up and down. Are you saying that they shouldn't do that? That would happen in a string, but if it's in parallel, they should more or less even out over time?
If they're hooked up in parallel, the output voltage is going to become basically the average.
I get that, yes.
Yeah, I don't think it affects the internal voltage. If you were to disconnect them, you know, from each other and measured, it would just be, you know, one would be 50, one would be 52. But when you hook them together, you're going to get 51. But then if you disconnect them, you're still going to get 50 and 52.
I guess my question was, their point was that if you have your batteries full over here to 100%.
Yeah.
Let me use percentage instead of voltage. Make it.
Yeah.
These at 100, and I put in new ones, but they're only at 80 when I start. Well, when they get charged back up, they're going to stop charging when one of them gets to 100, and when they go down, you know, these, depending on how it's done, it'll be the average. One will go below 50 if I have that as my recharge point, and one will be above 50. And they were saying that the differential, you're always, the new ones that are less than 100 would always be stuck 20% low, and they wouldn't, you know, they wouldn't equalize over time. Like, you know, if you think of it as water.
Yeah. How many charge controllers are you hooked up to? You know, it's the charge controller that's going to basically compensate.
It's all run in the inverter.
There is no charge controller hooked into the system.
No separate charge controller. The inverter controls it all. The inverters are wired together to act as one. You know, there's one master and 3 slaves.
Well, how are you controlling the charging? Like you run from your solar panels to the inverter, and then from the inverter to the batteries?
Yes.
And then from the batteries to the load?
Well, from the batteries back to the inverter to the load.
Are you sure there's not a charge controller just within that container?
There might be. It's all, if it's there, it's all within the inverter. There's not a separate charge controller.
Is this a Sol-Ark system that you've got?
It is, yeah. It is.
There's a webinar coming up like next Tuesday.
A week from tomorrow.
Yeah, I signed up for that because I wanted to find out a bit about Sol-Ark. That may be where we can find out, because it doesn't.
I can just call them. I've got like 6 of their inverters now, so.
Yeah, you're probably a gold customer or whatever.
They like me when I call that. They had me put at the beginning of the queue, so to speak. Yeah.
Okay, Bill, you had something to add on this?
Yeah, I don't know whether this is appropriate. Oh, am I on? Yeah, I'm on.
Yeah.
Appropriate or not, but when you charge or discharge, you want to connect the plus. If you have more than one parallel string, you connect the plus to the plus cell in one string and the negative to the negative cell in the other string, right? You don't.
Mm-hmm.
Yeah, normally they go to a standard bus bar, so you're not connecting directly to the other bank of batteries. Each one is coming up to a bus bar, so all the negatives from the strings are connecting at one bus bar, all the positives from the strings are connecting at another bus bar to make that parallel connection. And then that feeds off to the load. But in this case, you've basically got three separate systems. They just are kind of all working in parallel to each other. But are you driving from a common bus bar to all three inverters? Or three strings are dedicated to one inverter, three strings to another, two strings to the third?
All three are together. So I've got two set up now. So I've got a rack that's got 16 in each. So 4, 4, 4, 4. Wire them all together to the fourth. And there's two big bars that go up on each side of it.
Yeah.
Then I've got another one the same way. I cross the hots and the positives, the negatives to there. And then at the end of the negatives, 3 wires go up, one to each inverter. 3 wires go up from the positives, one to each inverter. And when I put the next rack in, I'll wire that in the same way and then move over the 3 to go up that way. I don't even know if I'd have to do that, but I probably will.
Yeah, so you're drawing from the entire battery bank to each inverter as they need it.
Yes.
Because you have so many hooked up in parallel, you might want to double check to see if that's causing any degrading of your battery banks. It might turn out that if you dedicate each of your racks, one rack to each inverter, you might actually be able to eke out a little more time for your battery bank. You know, it may reduce the strain, but that's something Sol-Ark should be able to tell you with their system. Because oftentimes with charge controllers, with a good charge controller like a Midnight Solar or an Outback, they're basically the same charge controller, just with a different label on it. But they have temperature sensors that go from that unit and attach to the outside of the battery. Do you have anything?
We have that.
Okay, so those are coming from your inverters?
Well, I just use the master into the middle of the battery bank.
And it goes back to the inverter, right?
Yeah, it goes to the inverter, and then the master controls the whole shebang.
So you have one sensor that's controlling all 3 inverters, or 3 sensors? One
sensor controlling all 3 inverters, because the wires are coming up together, so they're going to draw the same.
Yeah. Okay, so there's clearly a charge controller in your inverter unit, and that is there is designed to adjust for temperature compensation, because temperature will do the same thing like you're talking about. Is it undercharged? Is it overcharged?
And the Sol-Ark does have areas where I put in how much is for this battery, how much is the adjustment, the voltage per degree, so that it can do the calculations. It does have that in there.
Okay. So I guess to answer your question, I just don't know.
Okay.
You know, it seems like it wouldn't affect it, but the fact, especially for the fact that you're hooking them all together, you're basically drawing from one big battery.
And that is how when you go through the manual that they have, this is how they recommend, if you've got X number of batteries, here's the wiring diagram. Yeah. And they do recommend it all together.
Yeah. Okay. Yeah. I've just never heard of anyone hooking up that many batteries together in a single battery bank like that. So you're probably pushing the edge on it. So
I do that a lot.
Bill?
Yeah, I'm holding up a little device I've used on lithium battery packs. This accepts voltage from 8 cells that would normally be in series and reports the voltage. And they're cheap. They're on eBay. You're using lead cells, so you would have to put a voltage divider in to transform the 12 volts down to the voltage level that this accepts. But in other words, it just scrolls through all the voltages, and so you can get an instant reading of what the values are.
So with that thing, you say if you hook it up to a string, it'll measure each battery individually and just sort of tab through those batteries saying, first battery's at this, second battery's at that, third's at that.
That's
kind
right.
of thing?
It says number 1 and then the voltage, number 2 and the voltage, and 3 through 8, and it is self-sensing. That is, if you have 4 cells in series, it'll understand that. And not only that, there's a button on the top where you can program an alarm voltage where a beep goes off. You know, warning that the voltage is under or presumably over. Well, I think it's under a certain value. And
so that would indicate if you've got a battery that's going bad, or is it a cell that's going bad within a battery?
Well, in the case of a lithium, they're all cells, but in the case of a lead, it's 6 cells in series. But it would be if a 12-volt battery is under voltage, but of course you still have to put the voltage divider down to get it to 3.6 volts or something like that.
So I guess just for me to understand, is it measuring only at the cell level, or is it measuring individual full batteries that are connected in a string?
It's measuring each of 8 lithium cells connected in series and displaying the voltage of each cell.
Okay, but I guess I'm still going to push the question because there are individual cells within a battery.
Not a lithium pack.
Oh yeah, within a lithium battery, there are individual little cells that look like AA batteries.
I only deal with lithium cells. I don't have any lithium battery packs except where I've connected a bunch of cells in series.
Oh, so you're reclaiming old batteries and taking them apart and using the cells?
I have been into electric vehicles, and I have a lot of cells, you know, manufactured in China that I use.
Okay. All right. I just wonder if it would do what, Don, what you're looking at, where it measures the full battery, because your batteries are broken into these little cells within your battery.
Oh yeah, it also displays the full cell voltage too, after it scrolls through the individual cells.
Okay, so and then it would go on to the next one in the string?
Well, no, it displays the pack voltage and then each cell voltage, and the cell voltages add up to the series cell voltage.
Okay. So I guess I'm just visualizing, would you need 4 of those, 1 on each battery or 1 of them for each string of batteries?
one on each string of 4.
Okay. That'd be interesting. That would be pretty cool. It would then indicate if you've got a bad battery that's failing before it draws down your other batteries in that string.
Right.
Seems like a good investment, especially if you're into tinkering with stuff. If you're somebody who just wants to ignore it, well, then you shouldn't have got batteries to begin with. But, you know, you should have just gone with a grid-tied system and pretended it wasn't there. So, okay. Does anybody else have any other questions here? Anything? Tim, do you want to talk a little bit about the system you're about to install?
I'm not sure I know anything about it.
Well, Tim Chavez, he's in Columbus, and he's going to be working with us. We're doing a class in Columbus, well, an online class, but then it culminates in an installation where the students who are taking part in the online course, they'll take the ETA certification exam, and then we're going to show up at Tim's house in Upper Arlington in Columbus, and then we're going to install a 3.8 kW ground-mounted microinverter system. So that's, I was just looking at some of the parts for you, Tim. And how many of you guys out there are familiar with the microinverters, have installed an N-phase microinverter system? Anyone, Bill? Bruce, you've installed one? So I was looking, I know when Bob from Chicago is on here a lot, he likes to install the N-phase. And they now have a, do they call it a combiner box? I think they do, but it basically takes the Envoy, which is the communication system, and it integrates it with a combiner circuitry box. And so if you're wanting to bring in, say, for instance, 3 branch circuits, they're not strings because they're AC and they're basically being connected in parallel. But you can come with up to, it seems to me, about 16 or 17 microinverters in a branch circuit before you exceed the 20 amp capacity of the wiring for those parallel connectors. Well, this unit, you can bring in up to 4 of those, and they terminate at a 240 20 amp breaker in this little combiner box unit. And then the communication system is integrated into it as well. So it's powered from there. The older version, you had to use a separate 240 breaker, double pole breaker in your service panel to service the communication system. So to install an Enphase system required basically 4 empty ports in your electrical service panel to make the connection. One to connect your array, and then which takes two places on a 240 outlet, and then a double pole breaker for the monitoring system. So this is essentially you're installing a sub panel that then connects in but keeps your Envoy, your communication system, separate. And this communication system not only measures how much is being produced, but it also measures amperage and time of day usage. So it's really designed for places like the California market, where you start getting into time of use pricing. But the other thing that this combiner box will do is it allow for battery storage to be integrated at that box. So it's kind of nice, Tim, when we go to install that unit, it will be mounted on the outside of your home, right next to the AC disconnect. You then have to bust through the wall and make the connection to your service panel, but it's just basically connecting this sub panel, which is outside, to your main panel, which is inside. But then there are 3 additional 240 ports, one of which could be used for battery backup storage if you wanted to add like an Enphase, or you could even add a Tesla Powerwall if you wanted. And it would be mounted just right outside next to it and hooked in there. And it also has Wi-Fi connection through your cell phone service so that it's reporting that way, so you don't have to worry about hooking up modems and all that other good stuff. So it's a pretty,
to be able to monitor. Mm-hmm.
Yeah, it's a pretty cool thing. I think it also, if I'm seeing the new version right, I was looking for a video, but I didn't find one. I've become 22 years old. I don't read manuals anymore. I only look at videos to see how the thing works. But so anyway, I think it also has display units in there. So you could even monitor the usage of that thing without having to go online. You can just go out and look at the box, and it'll give you a little menu, which is something they were getting away from, but now they're starting to get back to, so that you can, it's sort of a 1.0 kind of feature. You can go out and push a button and see how much your thing is producing, which is nice, as opposed to having to go online. Mm-hmm. So it's pretty cool, but unfortunately it's a little bit pricey. That unit is like $675 just for that sub panel. But it does a lot of stuff. And just the modem to monitor the system used to be like almost $500. So so between the two, it's not that bad. Plus Tim's getting free, you're getting free labor for the whole thing, free design work. So, you know, who cares? So anyway,
what would be the alternative, though?
What would be what alternative? Oh, you just have to run straight into your service panel with 2 double pole breakers, and then you'd have to hook up your monitoring device there in your basement. So you basically save yourself $150 and make it a lot more difficult, and not as flexible in the future, because we're designing this system to triple in size should you decide to do so in the future. So Right now you're designing it with 12 panels, but we could go up to 36 and still keep all of the existing wiring. So I figured that that would probably be enough. You guys, your house isn't big enough to really require more than that. I couldn't imagine.
I don't think so. No.
And Tony, aren't you signed up for the Columbus workshop? Yeah, so meet Tim. You're going to be working on his house. So he's going to feed you those days somehow. He may not know that yet, but they're going to be feeding you. So
Tim, I'm also in Columbus. I'm Ricky. I was in Jay's class out in Zanesville in January. And
okay.
If you guys do have space, I'd love to help out and just learn.
Yeah, I think we will. So make sure you join. This particular workshop is going to be it's going to be supporting some of the funds are going to WGRN in Columbus, a community radio station. You asked the dates. I think it's the weekend of May 26th or 27th. I might be off by a day or two, but it's that weekend.
I thought it was 23rd and 24th. I'll
Could be.
have to look that up again.
It's those 20 something in May.
22nd and 23rd would be the Saturday and the Sunday.
Okay, so it'll be the 22nd.
Yeah, it's 22nd and 23rd.
Okay.
So the week before Labor Day, or Memorial Day. Yeah.
Yeah. So it should be good. It should be warm enough. We should all be free of COVID by then. We're hoping. So.
All right. So Jay, what kind of ground mounting is going to be? Are you going to have us? If somebody were to volunteer, will we be digging the holes for the posts?
No, what Tim has to do before we get there is he will have dug and cemented in the vertical piers.
Okay.
So there are 8 of those that are going to be in place. And ideally, he'll have it trenched from where we'll be running the wire to the house.
Exactly.
So that's where we're going to be. Then we'll put a laser level on the posts and trim them off level. Then we'll put the top caps on, then we'll put everything else on. But the posts will have been there and setting for hopefully a couple of weeks before we show up. So
I'll invite everybody for that too.
Yeah.
Well, if they, it'd be a good thing to watch to see how it's laid out. And,
sure.
What system is the post? What kind of system you put in? A Unirack or the
Iron Ridge?
Iron Ridge. Okay.
Yeah.
So it's got a front and a back.
Yeah. Yeah.
Okay. Yeah. I mean, I found the hardest part about doing the ground mounting thing was putting in the darn post and getting them to line up properly.
Yeah, it's really going to be, well, fortunately, the Iron Ridge system is pretty forgiving. So, we were just showing the piers are going to be 7 feet apart, east and west. So there are going to be 4 of them on essentially 7 feet apart. And then the north-south piers are set something like 7 foot 6 inches apart. So the question is, can you get those things all squared up, properly set? If you're off by 3 or 4 inches, it's not going to matter because of the way the system works. It has a lot of forgiveness, but it'll look not as good, So we want to get everything squared up. So you just measure the diagonals, make sure you get everything properly oriented. We want it to be exactly, 180 degrees facing south. We can set the pitch for the ideal, which in this region is going to be anywhere between 25 and 35 degrees pitch. They often just say 25, but it seems to me when I measured Columbus, it was like 28 or 29 degrees is perfect, but there's only like 1% difference anywhere in there. So we get a lot of fudge there as well. And then we'll decide how high you want to be up off the front. You can raise it up. They say 2.5 feet up in the front and about 6 feet in the back, but you can go higher. That's what I did so that the goats.
I was thinking about that too. I was going to discuss that with you, maybe being 4 feet up in the back, in the front.
Yeah.
Just a little bit higher.
Yeah. If we do that, I would suggest we get some diagonal bracing. But we can do that with just the top ridge of a chain link fence. Go down to Home Depot and buy that stuff. That works really, really well for diagonal bracing. In case you guys are trying to visualize what we're talking about, these piers are essentially 2-inch Schedule 40 galvanized pipe, and there are going to be 8 of them. But you know how the metal hollow tube is on top of a chain link fence, you know, that everything sort of hangs on? And then you have those little cups that fit over the end of it, but they have a little bracket clamp so you can adjust them a little bit. Well, if you clamp those on the 2-inch posts with the cup, you can set the metal at exactly where you want it to be. And it's a really nice, cheap diagonal brace for those systems. Iron Ridge, you can buy them for about 10 times as much money. They have their own little system. Or you can go to Home Depot and buy just those other bits, and they work just as well.
Yeah, it's basically chain link fence hardware.
Yeah.
Yeah, like what you have at Blue Rock Station.
Yeah, and in fact, one of those diagonals is bent out like a C because the goats went ramming it with its head and didn't do any damage to the array, but it sort of bent out the pipe. So I'm glad I have them. But
yeah.
So it makes a nice little place in case you want to, you know, put some stuff under there. Use it as a little outdoor storage area for who knows what you may store. Hoses, you know, lawnmowers, whatever it is you want to. You don't have a wood burning stove, do you, in your house?
No.
Or a fireplace? But you could store firewood under it, things like that.
So Jay, there's no spacing between the panels that would leak down?
Yeah, it would.
Oh, yeah.
Yeah,
that's what I thought. The spacers would be like an inch, yeah.
Well, there's no space in the columns. You know, they rest right against each other, but the sides, there's like about a 1/2 inch for the width of the bolt that holds those. So yeah, although they do sell some little drip molding kind of thing for that. So if you want to try and make it semi-drip proof, you know, it's a little thing that clips in there, and it's not going to be 100%, but it'll protect a fair amount. But for the most part, you're already outside. The sides are all exposed. You're going to get wind blowing. So it's never going to be 100% waterproof. But, you know, you can park a riding lawnmower under that or whatever, and it certainly does better than just leaving it out in your yard. So that'll be a fun little system. I anticipate we should be able to put that thing up pretty quickly. I'm not going to rush it through like we did. We put up one in Pennsylvania, and we had 18 panels, and we had a class. I think we had about 8 or 10 people working, and we started at 8 in the morning, and we were done by lunchtime, and the whole thing was finished, except for the programming of the monitoring system, which then took me until about 6 o'clock that night to get the communication system working to monitor the solar output from that. And it was funny because they had a little straw bale cabin there that I was staying at, and we had just hooked up this solar array. Everything was perfect. Everything was really nice. And at about 8:30 at night, all of the electricity went out, and the owner came running over, banging on the door saying, "What the hell happened? What the hell happened?" And we looked out, and the whole neighborhood was dark. So turned out it wasn't my fault. It was just that there was a grid outage. So
yeah, and then he said, "What good is this system?"
Yeah, what good is this? We don't have
if he had batteries there, he wouldn't. If he had batteries, he wouldn't even know that the lights went out.
Yeah. Yep. Well, that's where we're going in this world of today. Everybody's going to be moving to batteries.
Jay, I can sort of just walk. Can you turn over the screen to me? Let me just show a little bit about what the permitting process is going to be, if I could do it real quick.
Yeah, I think you just take screen share. I don't think I have to turn anything over to you.
Oh, share screen. Okay, cool.
Yeah.
Well, let me figure this out. Can you see that?
No. Did you click the green little box at the bottom of your screen there? It says screen share.
Yes, I did. Okay, a box popped in. How do I browse in this thing?
Oh, you just click on the box now you want to see or share,
Oh, okay.
and then it should go ahead and show it to everybody, I hope.
Okay,
There
see
you go.
that?
Yeah, it's starting.
Okay, this is the Upper Arlington Building and Planning and Zoning. And what I wanted to show you is the applications and permits already have established. I guess I'm one of their clients. I'm in the system, and I clicked, and I go into my account, and this is my account. So first off, first hurdle I did get through is that I can act as my own contractor because they want a contractor to install. So I'm registering as a homeowner, UA resident, and really everything about that. Oh man, I'm getting that stuff.
You're going to sign up for Netflix if you keep this up, right?
I know. I don't know what happened. I got an extension to my damn thing, but regardless of that, is that, let me get in there.
I noticed that the fees there for you, it looked like they wanted like $375.
Yes. Yeah, $375, and then $100 per certain amount of square foot. So
Square foot of the solar array or square foot of your house?
of the array.
Huh.
Okay, so let's go back to that. Okay, this is a permitting process of getting the building permit. So I made application as the contractor.
Uh-huh.
Then, so just basically asking information about the property.
Residential, yeah. Lot
Right.
area, 1/3 of an acre.
Right, contract information, that's me. And this is what I need to finish up in order to complete this application. I need to tell how many solar panel description. So I haven't done that yet because I don't know what the value is going to be and how many square footage, because that's what I'm going to be. That's what I'm going to be paying for the permits. And then what I have to submit is 2 paper drawings of the building and construction plans, along with the digital that gets sent to them. I need electrical systems description, which is going to be in the building and construction plans. And then I just need a site plan. And once that gets submitted, then they're going to review. I think our biggest hurdle is that we are using that engineering program. What's the name of it, Jay?
From Iron Ridge?
What's that again?
From Iron Ridge, you mean, for the
Iron Ridge,
ground
right.
mount? Yeah,
Yeah,
I don't
for the
think that
ground
should
mount.
be a problem because it is stamped by professional engineers when it's all done. They have a big thing on their site that if your building permit people have a problem, call them up and their professional engineers will discuss it with them. But I don't
Okay.
think your city's going to have much problem because it is ground mounted. It's not like it's going to be a structural issue for your house.
Exactly. And also that they took in, like you said, they took into account the zip code in order to calculate the wind load and all that.
Yeah, they calculate wind load. They
and the
also
snow
calculate
load.
snow loading. Yeah.
Right.
So it's pretty cool.
It is pretty cool. I really like that. So this is just really what needs to be submitted, which what Jay is helping me with as far as working that out. So to get it started. And
Yep.
that's
Now, do your
really
drawings
about that
have
now.
to be? Do your drawings have to be stamped by your electrician?
Good question. I'll ask him that today.
Yeah, because you are required, and this is very common, to have an electrician do the final connection to the service panel.
Oh yeah,
So
definitely. I'll talk to my electrician, John Lotus, and he has to register too as an electrician in Upper Arlington. So there's a good chance that the engineer will have to pay, or I'll have to pay $100 for the engineer for them to accept their plans, because it's $100 registration to be accepted as an engineer or as an electrician in Upper Arlington. So
you might also want to check, because when we did Laurel's system in Columbus, we not only had to pay the permitting fee, but then we had to pay for an independent inspector to come out and inspect the system after it was completed.
okay, so an ETA certification won't work for that?
No, they wanted somebody on their list in Columbus. And so the guy we hired to inspect it, I had to tell him everything he needed to look for, and then we had to pay him. So, and then he found fault with stuff that wasn't even required. So we had to fix that. Right. So, well, they always have to find something. So when you go to do this, we'll have to figure out what we're going to leave off so that he can find something wrong and we'll fix it. So we'll do something that's really cheap.
Maybe next week we'll show you the drawings, the engineer drawings, how that populated and came up. That'd be cool.
All right, so you can stop sharing at this point. I think.
So how do you stop sharing? Okay, see it.
There you go. All right. Okay, so we're getting close to the end here. Does anybody have any other questions or news for the good of the group? Nothing? Okay. All right. Well, I appreciate everybody joining. So we'll meet again back noon on Tuesday. Take care. Invite your friends. Great. Also, these are recorded and we post them. So let people know that too if they're interested.
Okay. And that's going to be on Solar Installers?
Yeah, it'll be on Solar Installers. It'll be on our website and it's on YouTube. So if you just look up for Solar Noon Tuesday, you'll find it. Solar Noon Tuesday. Okay. It's on the Blue Rock Station YouTube channel. If there's a whole bunch of stuff in there, so you can spend your afternoon binge watching Solar Installer Tuesdays or something. So.
Not a bad idea, actually.
Right.
Hey, can you after you finish recording, Jake, can we talk a little bit?
Sure thing. Just give me a call.
Okay. All right.
See you guys.
Thank you.
See y'all later. Bye.